So in today's class, we are going to continue the yesterday's concept. So that is what conservation of mechanical energy. So conservation of mechanical energy, we derived two formulas actually in our yesterday's class. So what is the first formula? If there is a work done by conservative forces, that is non-conservative forces, then work done formula is equals to what? Work done by external force plus work done by conservative forces is equals to final mechanical energy minus initial, yes please, initial mechanical energy.
Mechanical energy.
Final mechanical energy, this is the initial mechanical energy is equals to work done by external force divided by work done by non-conservative forces. If basically we know that if the given surfaces are smooth and there is no external forces, 80% cases, so that we all can say that final mechanical energy is equals to initial mechanical energy. So that is what we can say. Kinetic energy, final kinetic energy plus final potential energy is equals to initial kinetic energy plus initial potential energy. So this is what we'll use this formula when the given surfaces are frictionless surface or there is no external forces applied by the object. And we have derived that if any object is freely falling, as we noticed that yesterday's class we have done that we are having this use. So before touching the ground, what is the velocity, final velocity, which is equals to how much, everyone? Root over 2gh. We have done or not? So as it is initial velocity is 0. So with the help of yes, please, respond all of you. So we can find final velocity is equals to root over 2gh. Yesterday we have solved or not? Everybody? Yes. So now, with the help of that, yesterday we have completely focused on only one kind of forces, that is what spring related problems. Now today's class we are going to make spring as well as incline related problems, means the inclined surfaces, how it will be making. So inclined surfaces already a previous knowledge which we studied in the previous chapters. So for example, just I am making that again. So if the body is here, all of you observe, if the body is here, we all know that weight of the body is acting downwards and perpendicular, normal. So that what is the component? Normal is equals to how much in this case? Please remember and tell me. Normal is equals to what? Inclined surfaces. mg cos theta, and y-axis, x-axis, that is what? mg sin theta. You all remember that?
Sin theta.
So in these cases, n is equals to what? mg cos theta. If it is on the surface, then normal reaction is n is equals to mg. So keep it in mind that. Is everybody clear? So if it is in the surface, normal surface, n is equals to mg. If it is on the inclined surfaces, normal reaction is equals to what? mg cos theta. If the resultant force in the two components, suppose if here is the theta, then what will happen here? Here, yeah, suppose the resultant force is Fg or F is equals to mg. So mg, this will become what? Mg cos theta, and opposite one will become what? mg sin theta. This is what the previous knowledge which we studied in the previous chapters. If you remember that, that's easy to solve the questions. I hope who else is missing? Mr. Sai Karthik, Rishi informed, brothers informed, Mr. Narayan Murali also informed. Called that Monish. Who else is missing? Two more. Mr. Kadri is also there. Aswita. Manya called that Aswita and somebody called that Monish. So now, let us see now today's class. We are going to see the inclined surfaces. So spring surfaces we have seen in the yesterday's class, how to prove the conservation of energy. So in today's class, we are going to make it what? Inclined surfaces. Okay. So be very attentive. If you are having anything doubt, you can kindly ask me. So there is an inclined surface. All of you observe. There is an inclined surface and a mass m is traveling. So that is what the displacement of the body to come here is S. Okay. So understand the question. Many times I will rather do. So its inclined surface angle is theta here. And this is the height of the triangle. So the inclined surface. So here is the theta. Then can you tell me here what will happen? The displacement is S. Then here what will happen? Here S cos theta. And here what will happen? S sin theta. And it is the frictionless surface. What surface it is? Frictionless surface. Means in the sense of it is a smooth surface or rough surface. Everybody. It is the smooth surface. Okay, it is not it is continuing. Question is continuing. Just I'm explaining you. So as it is sliding from the top, so that what is the initial velocity? Velocity of the body. At the initial velocity of the body is equals to what? Everyone?
0.
0. So that is what you have to remember. Okay. Now this body has to come and basically observe there is a spring actually. So the spring is up to here. So let me take it. There is a spring actually. So now generally you consider the spring is up to some distance. The spring is up to some distance. So that is what it is here. But this body will fall and it will go and will hit. This means definitely that the spring will compress. Am I right or wrong, everybody? Yes, please respond.
Yes, sir.
That is what the spring will compress. So that is what we have to find it. So how much the spring will be compressed. So that is only is our target. So now what is the spring constant, everybody? Spring constant K. So this point is a what length? Yesterday also we studied. Up to this point is a what length actually? It is the, yes please. It is a what length? Natural length. Now, because of this body sliding and coming and hitting, so that it has been compressed X meters. So find that X. That is only is our question. Do you all understanding, all of you? Everybody? Yes, please. So now our question is that find the distance. Find the distance covered up the inclined surface by the block. So that is what is our question. So there is no, this is a smooth surface. So smooth surface means we have to use it what formula? First formula, second formula. Everybody, we have to use it. First formula, second formula. Frictionless surface. Yes, please.
Second.
Final kinetic energy plus final potential energy is equals to initial kinetic energy plus initial potential energy. Now all of you observe very carefully. Now final potential energy is what? Anybody? Body already comes to rest. Already it is traveled some distance. So it came to the final point. So what is the final potential energy? Everybody.
0.
Now final kinetic energy. What is the final potential energy? Everybody check it. What is the final potential energy? Body came from
0,
this.
sir.
Check it, Rudreswar. Body is coming and it is compressed. It is compressed it. So it is coming from this height. It is coming from this height. And it is compressed. So final potential energy is 0 or existed. Yes, please. Check it here. The body is coming from the height. Am I right?
Yes, sir.
Yeah, it is coming and hitting. It is hitting the spring, so that spring is going to be what? Compressed. So that final potential energy is there or not? Yes, please. So final potential energy will be there. That is what? mg, which is acting downward direction, and it is came from a height of how much? Height of how much? What is the distance traveled by the body? Everybody. Yes, sin theta. So what is the final kinetic energy? The final potential energy? Everybody. mgs sin theta. mgs sin theta. Now, next one. So now the initial kinetic energy is what? Body is at rest initially. So that initial kinetic energy is also 0. Understanding, everybody? So initial kinetic energy is also 0 plus. Can you tell me what is the initial potential energy? Body is at what height? Body is at somewhere here.
Yes, sir.
But the spring is what? Spring is at initial potential energy. It is having that. So what will happen? What is the potential energy of the spring? Yes. Potential energy of the spring, how much it is? Actual length is here. Natural length is here, but the body is here now. So what will happen? Initial potential energy. It has been compressed. Understanding? So it has been compressed so that what is the initial potential of the spring? Everybody. Spring is compressed or extended. What is the potential energy of the spring? Half into what is the potential energy of the spring? Half into k into x square. So that is what it is. So half into k into x square. So mgs sin theta, which is equals to half into k into x square. So if you solve this equation, we will get what? This 2 will come this side. So k value, if they will give, you can substitute it. So kx square is equals to mgs sin theta, 2 mgs sin theta. So x square is equals to 2 mgs sin theta divided by k. If they will give you theta value, if they will give you k value, you can substitute it and you can find what is the x which has been compressed. So that is what we can find it. So find the distance covered up in the inclined surface by the block. So we can find that everything with the help of this formula. So that is what, if you want to find s, you can find, either you want to find x, you can find. So this is how we have to solve inclined surfaces. If you solve next to sum and coming sum, so that you all understand very clearly. Okay, so just hold it. If you're having still anything doubt also, once you solve the next sum, you'll be having more idea. Okay, so next sum you take it. So next time is will be very, very challenging. So try to understand. So there is an inclined surface. Okay, so which is above how many meters? 3 meters height. What is the height of this inclined surface? Everybody? Yes, please. 3 meters height. So which is making the 37 angle. So we all by this time you people knows 37 means angle means it is a which triangle? 37 triangle. So 37 triangle
Four
means
by
yeah, here they are saying 3 means automatically
3,
how much? 4.
4.
Here how much it is? 5.
Hypotenuse 5.
Please remember that. Okay, that you have to remember. And there is a 1 kg object. How many kgs object? Please all of you observe very carefully. How many kgs object? 1 kg object. So now body will travel in this direction. So now always if it is moving, I am not mentioning it is a friction or not. So there is a coefficient. Coefficient of this friction is 0.2. How much it is? How much is the coefficient of friction?
0.2.
0.2. Means the frictional force will act what direction? Rudreswa?
Opposite
Opposite.
direction.
So the work done is negative or positive? Displacement is downwards, friction is upward. Display work done is negative or positive? Everybody.
Negative, sir.
Negative. That we will study. That's fine. So keep it in mind. The body is sliding. So there is a distance between from this point to this point is approximately 2 meters. First understand the question. Now there is a spring whose spring constant is 50 Newton. 50 Newton per meter. Okay, everybody. Now the spring is having a natural length something. So this is what is the natural length of the spring and whose this surface, of course all of you observe from this point, this is also a surface whose coefficient of friction is equals to 0.5. So means this surface and as well as this surface, both surfaces are rough surfaces or smooth surfaces. Everybody? Yes, please. Both are
Of sir.
rough surfaces. Means both are exerting the frictional force or not? All of you understanding what I'm saying?
Sir.
Everybody? Now, this body will start sliding and it will travel this 2 meter distance also, and as well as it will compress this spring. It will compress this spring. Actual length is this much. The natural length is this much. It has been compressed this much. Do you all understanding what I'm saying? From this point to this point, it has been compressed. Clear, everybody? Please respond, all of you. Understand, Amma? So that is what
Sir.
we have to find it. How much is the x it is making? So if you solve this question, 90% concept you will understand. Now here also you see that the spring is moving in this direction and the frictional force will act what direction? Frictional force will act opposite.
Opposite.
So here also work done is what? Negative or positive? Everybody. Work done is negative. And here also body displacement is downward direction, frictional force is upward direction. So here also work done is positive or negative? Fastly, everybody. Yes.
Negative.
Negative. So now which formula? Friction surface. It is a non-conservative force. So which formula we have to use it? Work done by external force divided by work
First
done.
4.
Yeah, work done by non-conservative forces. That is what friction. Am I right or wrong? Everybody.
Yes, sir.
Equals to final potential, final mechanical energy minus everybody initial mechanical energy. So basically, as I said, work done by the external force, no external force is acting. So that work done by external force is equals to what? Yes, please. 0. Now work done by conservative forces means work done by friction. Am I right or wrong, guys? All of you understanding? Yes. Now, here if you notice it, this work done is also two types of work done by conservative forces, because here also friction is exerting. In inclined surface also friction is exerting, and here also friction is exerting. So, work done by friction is 1 or 2. Anybody can tell?
2.
Work done by friction, 2. That is what? Work done by friction in inclined 1. Work done by friction in inclined one, which is equals to work done by friction in what? This is what we used to call horizontal. Understanding? So work done by friction in horizontal, which is equals to final mechanical energy minus initial mechanical energy. Do you all understanding, everybody? Clear? Please respond, guys. Everybody?
Yes, sir.
Now we all knows that friction formula mu into n. First, let us see for the inclined surface. Inclined surface means normal equals to. Can you tell me? We all studied even beginning of the today's class. I told you. So inclined surface normal is equals to, as it weight is acting downward direction. Normal is equals to what? Fast is
mg cos
mg cos theta. This will become
mg sin
mg sin theta. Adi theriyuma, that's enough. So what is the friction? The frictional force on inclined surfaces. Sorry, let me take work done by inclined surfaces. First, I will find friction, how much it is. Then we can find work done. So what is the work done formula? Work done by frictional force, inclined frictional force is equals to force into displacement. Am I right or wrong, everybody? Do you all agree with me? Please speak, guys.
Yes, sir.
Yes. So now, all of you observe and tell me. Now, all of you observe, the force is equals to formula. That is what? Frictional force is equals to mu into n. Mu value, how much they have given? Check it, everybody. Mu
0.
value 0.2. Now, normal means what? Inclined surfaces, normal means what? mg or mg cos theta? Speak loudly.
mg cos.
mg cos. So now mg cos theta, 0.2 into m value, how much? 1 into g value is 10. Cos theta, check it, everybody. Cos, how much they have given?
37.
Yes, 37. They're all very familiar with the triangle. So cos
4
37
by 5.
answer. Cos 37 means, all of you speak loudly.
4
3,
by 5.
5. So which is 4 by 5. So can I write this one as, which is equals to 0.2 into 1 into 10 into 4 by 5. Brothers, can you able to understand? That's all it is. So 0.2 into 10, 2. To 2 into 4 by 5 is the F into what is the displacement? Sir, displacement they're not mentioned, sir. I can find it. From here to here, anybody can tell me. If this is the 3 means, then here automatically what? Triangle. This is the 4. Then 5 will become the what?
5, sir.
5 is the
Displacement.
Sir, they're not given how we can find, sir, because it is a 37-degree triangle. So that automatically hypotenuse is how much? 5. Am I right or wrong? Yes, please.
Yes, sir.
5 will get cancelled. The work done by frictional force in inclined is equals to how much, everybody? Yes, please. Work done by inclined, which is equals to how
8
much?
joules.
8. 8 joules, you can make it. Now, horizontal, check it. Horizontal total it is traveling how much distance? The body is coming and it is traveling from here to here. How much it is? 2 meters, and then it is compressing the spring.
2 plus x.
Meters. How many meters? Yes, please.
X. 2 plus x.
So, work done by frictional force. I hope everybody able to catch the point. Everybody understanding, Amma? Girls? Work done in horizontal. Horizontal is equals to, again, same formula. Force into displacement. Now, force is equals to what is the formula? Mu into n. Now, n is equals to what? Anybody can tell me? N is equals to normal. Am I right or wrong?
Only mg, sir.
So, mg or 2 mg? Just mg. Am I right?
Yes, sir.
mg. And mu is equals to mu mg. So, mu mg.
0.
Yeah, mu mg into displacement is equals to how much? It is traveling 2 plus
2
x.
plus x.
So 2 plus x. Understand the Pradosh? So I got it. So mu value is how much? 0.5 into m value is how much? 1 into g value is 10 into 2 plus x. So 10 into 5, 5. Understanding? Into 2 plus x. So this is what? Work done in which direction? Everybody. Yes, please. Horizontal. Clear, all of you? Now, both you observe, horizontal also displacement is in this direction, friction is in this direction. So work done is negative or positive? Please.
Negative.
Negative. In inclined surface also, displacement is down, friction is upward. So that here also work done is what? Everybody? Negative. Clear? So I'll substitute this both the values. Minus of 8 plus 5 into 2 plus x. Will you all agree with me? All of you understanding? Which is equals to final mechanical energy minus initial mechanical energy. Do you all understanding, all of you? Yes, please. So body is already compressed. So can you tell me what is the potential energy? Sorry, kinetic energy, final kinetic energy. Let me write this one is same. Minus minus 8 into 5 twos are, okay, I'll modify this one. So small bracket, I'll put, so 5 twos are 10. Let me modify, 5 twos are 10 and plus 5 into x, 5x. Is it okay, guys? Everybody clear? Now, can you
Yes, sir.
tell me body is already compressed, so it came to rest. So final kinetic energy become what? Fastly
0.
0. And finally, final potential energy. The spring is compressed. Spring is compressed. So what is the final potential energy? Speak loudly, guys. Spring is compressed. So what is the final potential energy? Half
Half kx square.
minus body initial kinetic energy. It is a 0 position. So what is the initial kinetic energy? 0.
0.
Now body initially at where? Body initially at inclination. What height it is?
3
What
meters.
height it is? 3 meters per second. So it will become 3 mgh. So mgh is equals to how much? mg3. Am I right or wrong? Everybody?
Yes, sir.
Yes. That is what.
Yes,
So
sir.
the initial potential energy is equals to mgh. Is it okay, Rudreswa? Understanding, girls? All of you? Yes? Yeah.
Yes, sir.
Let us go with the things. Now, if you notice it, so if you solve this one, you will get it. So minus of 8 plus 10 plus 5x is equals to, this one 0 will get cancelled, half kx square, and this one minus into plus minus mgh. H means value how much? Let me take 3. So we all knows that g value 10, m
And
value 1, and h
1.
value is
That's
equals to,
equal to 3.
so which will comes minus 10 minus 8 minus 5x, which is equals to half kx square minus 1 into 10 into 3. Am I right, guys, everybody? So it will turns into half into kx square minus 30, which is equals to minus 18 minus 5x. Am I right, all of you? Understanding, Amma? Yes? Please respond. So now
Yes,
if I
sir.
take this one, minus 30 will come this side, it will become plus 30. And minus 5x will come this side, what will become? Everybody, please respond. Plus 5x. Clear?
Yes, sir.
Yes. So now you can make it 18
12.
30. How much is the answer? 12.
12
Yeah, 12.
into 2.
Yeah, 12. Now you can make it here. What I can do it?
Sir, LCM and multiply 2 this side.
Yeah, I will take LCM 2 so that it will turns into kx square plus 10x and 2 will come this side. So can I write as a 2, everybody? Is it clear? All of you?
Yes, sir.
Yes. So I can say it is, or else we can see we have done mistake here. I have given a k value with this one. Why we need to do this one? We can finish.
Sir, 50, sir.
Yes. So that's what is my question. So 1 by 2 into 50. So that 2 ones are 225. So directly we'll get the equation 25x square plus here 5x, not 10x. Correct? 5x,
Yes,
5x is equals to 12. So now you'll form
Minus
the quadratic equation. So 25x square plus 5x minus 12 is equals to 0. So if you solve this equation, you'll get x is equals to 2 values. Is it okay, guys? Everybody? Yes or no? Please respond. That is only the answer. Understanding, Amma? All of you? Yes? Yeah. So please respond. So this is what is inclined surfaces. Now, there is this question. If you understand it, then there is another interesting question in this. So please have you all understand this question? How to solve? Everybody clear? Yes?
Yes, sir.
So that is what you have to remember it. So there is another question now. So all of you observe, this is even more complicated. So you have to be very careful. So there is a surface, plane surface, and then body is entering into circular path. Circular path. All of you check it. It is a what path? Everyone? Circular path. So circular path means something we all people knows. It is having a center. What is the center called as? From the center we used to call something. What is that? Yes, please. Radius.
sir.
Having a friction. So actually we consider as a smooth surface. So smooth surface means definitely it does not have what? Any kind of friction. Understanding?
Friction.
Now, if you observe very carefully, there is a rigid surface. So what is the question? Try to understand everyone first. So there is a spring force. Okay. And the mass M is attached. Okay. Now, so from this point, if I compress it, so if I compress it means what will happen, guys? Everybody, initial kinetic energy is what? Half kx square. Am I right or wrong? Initial compressed all. Clear? Please respond. Yes.
Sir.
So if the body has been compressed x meters, not 2 times arrows, 1 time arrow, all of you observe, it has been taken back, compressed. So first of all, tell me by the ground, what is the potential energy by the ground? Here, smooth. So it is on the plane. So that, what is the potential energy by the ground? Everyone? 0. Am I right or wrong? Because only it will do it when it is in elevation. So let me take it all of you. It's very challenging. So observe very carefully. Now, I want to compress this spring. You all people can play the game. If I compress the more and more, it will bounce up. Am I right or wrong? If my compression is very high, then the bouncing, flying off is also very high. Am I right or wrong, guys? Please respond.
Yes, sir.
So now, question you try to understand. I compressed this mass M and I left that mass in such a way that the mass is keep on going and rising. So let me take the point is P. What is this point, everybody? What is this point? P. Okay.
P.
Again, for this concept, you should remember circular motion. So circular motion is always something acting towards the center. What is that?
Centripetal force.
Centripetal acceleration. Or we can say yeah, centripetal force. So centripetal force, what is the formula? Centripetal force, the force exerted by centripetal force formula, please. mv square by centripetal force formula, mv square by r. So observe very carefully. Question first to write it. What should be the value of x? This x. Understanding, everybody? Value of x such that how much you have to compress it, such that the mass m exerts a force of mg on the curved surface at point P. Curved surface at point P. Is it okay, everybody? Do you all understand what I'm saying, everybody? So at what force you have to compress this? How much you have to compress in such a way that this body has to rise us, move, and at the point P, it has to exert a force on the surface. How much it has to exert? Which is equals to, speak loudly, everybody. Which has to exert a force of how much, Ra? Which has to exert a force of how much? mg on the curved surface at point P. So mg is equals to something. Basically, we all people knows that. Normally, if I take any kind of body, if it is exerting mg in downward direction, then upward direction, what is that? Normal. So n is equal to mg. Am I right, Rudreswa? Do you understand it?
Yes, sir.
Normal is acting in this direction. Now, all of you observe very carefully. As this body is taking into the circular path, till here it is traveling in that, then it is traveling into the circular motion. So we all people knows that centripetal force is equals to, what is the formula? Centripetal force. Everybody, respond. Centripetal force is equals to mv square by r. Now, all of you observe very carefully. If this body, the body is exerting mg force on the surface means, then the surface also will exert some normal reaction force on this body. Am I right or wrong, everybody?
Yes,
please. Which is only equals to what? Which that n is equals to only what? The force which is acting towards the center, we used to call something. What is that, guys?
Centripetal acceleration.
Centripetal acceleration. That is what we used to call. What is that? mv square by. Speak loudly.
R.
It means in the sense of these both are equal. Am I right or wrong? N is equals to, I will say, n is equals to mv square by r. So that n is equals to mg. So can I say that mg is equals to mv square by r? Am I right or wrong, everybody? Yes, please. So m will cancel. G is equals to, please understand, v square by r. From that, can you tell me v square is equals to what? Loudly, speak loudly. V square is equals to what? ZR. Understand, Pradosh? Because this body is exerting mg force at the point P. Means then P is also will exert same force on the body. Am I right or wrong? Or reaction. Where we have studied that. If this is the surface, the normal exerted by the surface on the body is upward direction means, then the body will exert the same normal reaction on the downward force. Am I right or wrong? On the surface. Yes, please.
Yes, sir.
Now the body is exerting at this point mg at the point P on the surface. Then surface also will exert some normal force. That normal force only which is acting centripetal acceleration, because it is a circular path. Centripetal acceleration equals to what is the formula? mv square by everybody.
R.
That is only equals to what? That is only which to called as what? Which is acting towards to the center.
Normal.
Normal. So that is what mv square by r. So mv square by r is equals to normal. Normal is equals to mg. We all people knows that. So mg, if we substitute, v square is equals to what is the answer we will get? Everyone? V square is equals
RG.
to mg. Understanding? So now body is finally reaches to this point. Body is finally reaches to this point. This height is equals to something. Anybody can tell? That height is equals to what? Speak loudly.
Radius.
Radius. Am I right or wrong? Can you able to catch it, guys?
Yes, sir.
Everybody? So HR. So that's all. So what is the formula you'll use? It is a smooth surface. So which formula? Final mechanical energy is equals to, yes, please. Respond. Initial mechanical energy. So final kinetic energy, tell me, body is having velocity. See, at point P also body is having velocity. What is the velocity? V square. So body velocity is not zero. Am I right or wrong, guys? Please.
Yes, sir.
So body's velocity is not zero. So that final kinetic energy is not zero. So what is the answer? Half m V square
V square.
plus, and body, finally body is at above from the ground. Check it, everybody. What height it is? Above from the
Radius.
ground. It is at. So that mg, yes, please. mg r. That r only is equals to h. Am I right, guys?
Yes, sir.
Yes. That is next. Body. All of you observe very carefully. Body initial kinetic energy is what? It is in state of rest. So then what is the initial kinetic energy?
0.
0. And initial potential energy, check it. Already body is compressed, x. How much it is? Compressed already. So how much it is? Initial potential energy, spring. What is that, guys? Spring is compressed so that it is released. So that initial potential energy in the spring is how much? You should spell. Spring is compressed. So that what is the initial potential energy?
Half kx square.
Okay. Understand, everyone? Clear? Please respond.
Sure.
That is what? So half into m into v square means we all knows that. Just now we have done. V square means what is the answer?
GR.
Square means gr. So I will write this one. So here mgr plus here also we are getting already mgr, which is equals to half kx square. So both the sides half will get cancelled. Now, sorry, it is not multiplication. It won't get, sorry. Yes. So now I'll make it, okay. Can I make it as a this one, mgr plus 2 mgr, then it will be cancelled. Am I right, guys?
Yes, sir.
Yes, mgr plus 2 mgr, which is equals to, then 2 will get cancelled. I will write it, which is equals to kx square. So if they will give you in the exam, what is the mass equals to, what is the radius equals to, what is the k value is equals to, then you people can find g value is always 10. So we can find the what? X. Am I right or wrong, guys? All of you?
Yes, sir.
If they will give you in the exam, you can find the what is x is equals to. So this is the formula. So this is how you have to solve conservation of mechanical energy in what surfaces? Everybody. Yes, please. Inclined surface.
Inclined.
Okay. Now, I will teach you one more thing. Just you have to remember. For example, you remember, if I'm having a body, one body whose mass is 2 m, not meter, it is mass 2m, and which has been attached with a spring and whose mass is 1 m. And these both the bodies are draw above from the height h. Above from the, please respond, above from the height h. Like imagine a ball is present, it is attached with another ball. Now it has been above from the ground with the height h. Now if I drop these two balls, this first ball will travel, for example, h distance means, then the second ball also will travel how much distance? Yes, please. Second ball is coming down, so the second ball also will travel how much distance? If the first ball will travel, for example, 1 meter downwards, then second ball also will travel how many meters downwards? Everybody, from the initial position.
1 meter.
1 meter. What types of display, types of motion you might be studied? Translatory motion. Do you remember, everybody? each part of the body will travel the same distance. Am I right or wrong, guys? Everyone? Yes? Please respond, all of you. So that is your remember. If this particular body will travel downwards 1 meter, then the upper body is also travel the same distance in the downward direction. Do you are understanding, guys? Everybody? Yes? All of you, please respond. Now my question to you is, what is the velocity of this body at initially? What is the velocity of this body? Initially, 0. Understanding? But when it will comes to this point, this second body comes to this point, can you tell me what is the velocity? Is it having a 0 velocity or velocity equals something? Imagine this is alone like a free fall. If the body reaches to certain height, what is the velocity is equals to? We have just now solved, which is equals to how much? Root over 2gh. So the second body will comes to this position and first body will move to this position. Then can you tell me what is the second body velocity at the point? Second body velocity is how much? Root over. Yes, please. Root over. Respond. Root over 2gh. Understanding? Now, at this point, if the second body will comes to this point, what is the velocity of that body? Which is equals to root over 2gh. Understanding? Now, if this both the bodies will come and hit, so this is 1 kg mass, 1 m, and it is spring, and it is 2 kg or 2 m, you can take it. They are above from the ground h. Okay. Now both bodies has been shifted. 1 h meters they have been traveled. Now can you tell me, like, it is due to the spring, so that after traveling to that, this body came here. So here this velocity is 0. Can you tell me what is the velocity of this body at this point? After traveling h meters, what is the velocity? Which is equals to what? V is equals to root over 2gh. This spring is going to hit the surface. If it will hit the surface, suppose I will hit the ball towards the ground. Is it will stop here? What will happen? What will happen, guys? Again, it will be bouncing back. Am I right or wrong? Yes? Please respond. So it will be bouncing back. So the same way here, this spring will be again, it will take the bodies to move upward direction. So again, this body will this body will travel 2 meters. And again, it will be, this body will rises and this body will goes to some other position. So by that time, what is the velocity? Anybody can tell me? Again, it reaches to maximum. So what is the velocity? Yes, please. From this point, it is reaches to again maximum height again. So what is the velocity? Anybody? Velocity.
0, sir.
It is rebouncing. Understand, brothers, what I am saying? Rebouncing time. See, when it is coming down with the velocity root 2gh. When it is going time also, from this point, it is going time also, it will go with what velocity? Root over 2gh. But when it will reaches to the top, what is the final velocity?